Students, hello students, welcome back to our channel. This is the part 2 of chapter number 10, Work and Energy Science. This is the physics video. So, I hope that you have liked the part 1. If you are not seen the part 1, go to the our channel and see the part 1. Otherwise, you will be have faced a lot of difficulties in part 2. Okay, so let's start with part 2 without wasting our time, because exam is near and we have to complete our course uh, at the end of the February, because you have to do practice in the month of March. Okay, so let's complete this chapter in this video. So let's start with potential energy. In last video we have done kinetic energy. What is kinetic energy? Let's recapitulate quickly. Kinetic energy, uh, energy which is kinetic energy is the energy which is produced by a motion of the object. So that is the definition of kinetic energy. Okay, so let's quickly see with potential energy. Definition of potential energy is: potential energy is an energy stored in a body. Potential energy is the energy which is stored in the body. You might have seen here that everyone was saying that your potential is very big, your potential is so high, you can do this because your potential is very high. Potential is you can do that work. The capability to do that work is there in your heart. Okay, so that is known as potential. uh, for example, when you take the arrow and in what is say arrow and it's tir kaman. Okay, in Hindi it is known as tir kaman. When you pull the rope and pull it backwards, so the potential energy is stored in the arrow as well as in the rubber. When you release it, the whole potential energy of the rubber, it's transferred into the arrow, and arrow leave the barn with very high velocity. So that is known as potential energy. So let's see definition as well as this its derivation. Potential energy is the energy stored in a body. Okay, stored in the body, that is stored in our body. My potential is very high, so I can do that work. Okay, so initially I am saying that I have energy to do that work. My potential is so high, I can do that work. The sufficient energy is present in my body to do that work. Simply in simple language, in Hindi I explain that. You can say uh, in Gujarati. Okay, in Gujarati, તમારા અંદરની ક્ષમતા તમે જે કરી શકો ને એને કહેવાય તમારું પોટેન્શિયલ એનર્જી. ઓકે, ઇફ યુ ડુ કેન ધેટ વર્ક, ઇટ ઇઝ નોન એઝ પોટેન્શિયલ એનર્જી. Okay, my Hindi is little bit 2090. Okay, 90-20, you can understand that. So let's take an derivation. So F is equal to W is equal to F into S. Work is equal to force into displacement. Work is equal to force into displacement. Work is equal to force into displacement. We have seen in the part 1 also. Okay, so I have already said that you have not seen the part 1, go the channel and see the part 1. Otherwise you have to face the difficulties. Now we have learned the formula F is equal to mg. We have seen the formula F is equal to ma. A is the acceleration, and in chapter number 9 we have seen F is equal to mg. G is the acceleration due to gravity. So we can put A as well as G, but we will put G only, not A, because A is in a term of on the road as well only, but G in a term of only and only gravitational force. So we will put G only. So we can write F as a mg, and I can write displacement as a height, because this is the surface. I take my hand from here and put here, so this is also displacement. But in a term of potential energy, you have to do the height. So this is the surface of a earth crust, and the object is over here, so the height is there, and this is also known as displacement as well as height. So we will put h. So by combining that, we will get mgh, mdh. Okay, there is md and here we have g. So by this mdh and mgh, you can learn this formula by mdh is equal to mgh. Okay, this is the trick to learn the formula of potential. So let's without wasting our time, let's move forward with conservation of energy. Now students, let's start with our law of conservation of energy. Let's start with our law of conservation of energy. Okay, so we have studied law of conservation of energy as well in chapter number 3, atoms and molecules. So same type of definition as well as the quantity and all the things are same as well here. So we will not do lengthier, we will complete it in the short only. The change of form into the other is called transformation of energy. That means one energy convert into another energy. That means take an example of solar energy. The sun is giving the radiation and the solar panel observe this radiation and convert into the electric energy. That means solar panel absorbing the sun energy and converting it into the electric energy. So sun energy converted into the electric. So one energy converted into the another energy. It is known as transformation of energy. I am repeating once again. One energy is converted. This energy is converted into this energy. So this process, it will be known as transformation of energy. Yes, students, transformation of energy. So energy cannot be create or destroy. We know that energy cannot be destroyed and cannot be created. In our universe, the energy present in our fixed quantity. That means energy, we cannot create energy as well as we cannot destroy energy. Okay, so from 1000 BC, 1000 BC, 100 BC, 2000 BC, the energy is constant towards to over here also. In future, it will be constant situations, and as we know, energy cannot be created or energy cannot be destroyed. But the people who live in 1000 BC ago, our we will known as Adi Manav in Hindi or Gujarati, old age people or our ancestors, they have not that much of knowledge to convert the energy into the another form of energy. That's why they are not able to create the light energy and another energy. So energy is constant from 1000 BC to in the future it will be constant. It will be not reduce or not increase. So as we know that it cannot be created or as well as destroyed. Wait for 2 minutes. Okay, we know that energy cannot be destroyed and cannot be created, so it will be not increase in the future or not decrease in the future. It will be constant in the future as well. Okay, so here we have complete our law of conservation of energy as well. So our last main topic is remaining power. So what is power? You are saying that I have that much of power, I have that much of six-pack abs of power, I have that much of power, I can speak louder, so I have much power than you, I have knowledge power than you, I have eyes power than you. So you are telling someone that you have more power. So what is power? Rate of doing work or ratio of work or time. Ratio of work or time. I have not written the formula, so let's quickly write the formula. W upon T. Power. Okay. So rate of doing work or ratio of work and time. Ratio of work and time and rate of doing work. These both are used to define the work. No, sorry, define the power. Okay, now let's see. It is also scalar. If you notice that the work, energy, and power, these three all are scalar quantity. They are not vector quantity. That means the all of them have magnitude only. They have not direction. Energy have only magnitude, not direction. So that means it is scalar. Energy is okay. Work has only magnitude, not direction. So that means it is scalar quantity. In energy, that is only scalar quantity. So it means that it is only it has only magnitude. It has not direction. Now in power, they have also written the scalar. So that means power also have only magnitude, not direction. So it is scalar quantity. Now it definition it formula is W upon T. W upon T. It formula is W upon T. Work upon time. Work upon time. You have to write. You have to learn like that. Work upon time. Work upon time. Work upon time. Work time. Work time. Work time. Work time. Work time. Work. Okay. You have to speak in the fast so you can remember it. Work upon time. Okay. So here is the formula of power. Now let's see. Its SI unit is what? Its SI unit is what? The SI unit of work is joule. Energy, joule. Okay, wait for 1 minute. Okay, it is visible over here, so I will write here. And okay, I am not able to. Okay, you can see the SI unit of work and energy are same, joule. But in power, it is what? And you have here that that car has 1,000 horsepower or 1 liter engine or it give 1,000 of horsepower energy. So 1 horsepower is equal to 764 watt. 1 horsepower is equal to 764. No students, 746. 746. 746. 1 horsepower is 746 watt. Okay, 1 horsepower is 746 watt. And 1 kilowatt hour. 1 kilowatt hour. That means 1 kWh. Okay, I have written kWh. 1 kWh. 1 kWh is equal to 3.6 into 10 raised to 6 joules. How it has been come, let's derive quickly. Okay, so you have to first of all learn the law of conservation of energy that we have learned in the chapter number 3. But one energy converted into another energy, which is known as transformation of sentences. The power SI unit is what? It is scalar quantity. Its SI unit is what? That is definition is work upon time, rate of doing work, and 746 horsepower. 1 horsepower is equal to 746 watt. Okay, now let's see how this has been come. Okay, let's continue with that. Okay students, let's calculate 3.6 into 10 raised to 6 joule. How this has been come. So first of all we can write like that 1 kilowatt, 1 kilowatt hour. So we can write like this 1 kilowatt into hour. We have taken hour separately. So we have taken hour as separately. And if you notice that 1 kilowatt is equal to 1000 watt. 1 kilowatt is equal to 1000 watt. So we can write 1000 watt. And 1 hour is equal to 3600 seconds. Okay, 3600 seconds and 1000 watt. So when you multiply, we will get 36000 in 00 and into joule. So we can write like this: 1 2 3 4 5 6 0.6 into 10 raised to 6 joule. From this, okay students, from this we got the formula From this we got the answer 3.6 into 10 raised to power 6, 10 raised to power 6 joule. Okay, so here our here this is the end of this video. Here this is the end of this video. I hope that there will be no any type of doubt in this video. And I want to tell something about this chapter. This chapter was very easy, and this chapter was very beneficial for them who want to take biology as well as who want to take maths. No, for biology students it is be more IMP, because the power, the work, energy, these all are concepts come in biology, in our body, in our muscles. But the concept of the formula of work as well as the height, we have to release that from, so that's come in the A group, that means in the maths. Those who want to take the maths, it is very helpful for them also. If you want to correct the IIT, JEE, NEET, this chapter is very IMP for them who want to crack the NEET and JEE. Okay, because there are most IMP topics are there in this topic, in this chapter. Okay, so in this video I am not going to give some IMP questions, but I am going to give you IMP topics. I am going to give you IMP topics. So first IMP topic is kinetic energy. First IMP topic is kinetic energy. Second IMP topic is law of conservation of energy. Law of conservation of energy. Okay, first is kinetic energy and second is law of conservation of energy. And third, at the third number I have put it potential energy. Potential energy. If you will do kinetic energy as well as law of conservation of energy by your heart as well as your mind as well as your body, you will be mastering this chapter. But you don't have to forget all the formulas of work, power, energy. You have to remember all of them, because might be one or two three questions can be asked from that concept. So you don't have to waste your marks in that type of questions. Okay, so I hope that you have liked this video. If you like this video, like, share and subscribe to our channel, and please support us. If you have any doubt, you can comment down below. I will clear a doubt as well as soon if possible. And this is the part 2, and we have completed our chapter 10, work and energy. Thanks for watching. तब तक के लिए जय हिंद, जय भारत.